working with algebraic expressions and working with algebraic equations. First, let's look at some of the different properties for real numbers, and we're going to extend this when we have algebraic expressions. For example, the commutative property of addition tells us that if A, B, and C are all real numbers, so we're going to work with A, B, and C being real numbers. With the commutative property, we know that A plus B equals B plus A. So, for example, we could say that 3 plus 1 equals 1 plus 3, because we know 4 equals 4. And also that 3 minus 1 equals negative 1 plus 3, because we could write 3 minus 1 as 3 plus minus 1. Therefore, it's easier to see by the commutative property of addition that negative 1 plus 3 would equal 3 plus a minus 1. So once again, we can write 3 minus 1 as 3 plus negative 1, therefore allowing us to use the commutative property of addition to say that 3 minus 1 equals negative 1 plus 3. The associative property helps us to associate different numbers together to make our addition easier. So A plus, and if we look at B plus C, we can add A to that sum of B plus C. Or if it's easier for us, putting A plus B together and then adding it to C. So for example, as we look at associative property, we could have 3 plus 7 plus 2. We could rewrite that as 3 plus 7 and adding 2. Because we know 3 plus 7 is 10, adding 2 we get 12. But we could also say the 3 plus and then 7 plus 2 is 9, also equaling 12. But if it's easier for us, when we know that 7 plus 3 is 10, and then just adding 2 would give us 12, associating 3 with the 7 might make the calculations easier. Of course, these are easy numbers, so any association really works. But when they get harder, it is nice to know that we can change things up. And if we had 3 plus 7 minus 2, I still could say 3 plus 7 and then add that minus 2. Because remember that that is 3 plus 7 plus that negative 2 inside of there. So we could use the associative property to rewrite it like that. Or that we could rewrite this as 3 plus 7 plus that minus 2 equals 3 plus 7 and then subtracting a 2. All of these different ways to write it are equivalent, and learning that and being comfortable with rewriting or regrouping numbers so that our calculations are easier is a very good skill to have. We also know the distributive property. A times B plus C equal AB plus AC. And remember, by the commutative property of multiplication, we could rewrite that as A plus B plus C equal BA plus AC, or BA plus CA, or so forth. Because we have a commutative property of multiplication that A times B equal B times A. And also, if I have A times B plus C, I can say A to the product of B times C, or I could multiply A times B and then multiply it by C. So once again, depending on what the numbers are, it might be easier for me to group different numbers together. And ultimately, this could also equal A times C times B. By the commutative property of multiplication, I could have taken that first one and said A times C times B, and then gone to this part. So again, I'm just showing you how to play around with numbers. So we're going to take a look at a problem that's going to show us the different grouping symbols that we've learned. So you could have braces, brackets, or parentheses, and that we have to go into the innermost part of our equation, the innermost parentheses, solve that first and work our way out by the order of operation. Then we do multiplication from left to right and addition from left to right. But we also have to remember we have these wonderful rules that we just learned through the commutative, associative, and distributive property that can also help us. So if we had a problem like this, negative 3 times x plus 3y plus 2 times 2x plus y. Since we cannot do anything inside of the parentheses, we must work on each of the terms separately through distributive property. This is term 1. A term is anything that is separated by a plus or a minus. So we have this one plus here. Now I know you see a plus inside the parentheses, but remember, we're taking negative 3 times that value. So it is not being separated by a plus or minus in this original form. So I'm going to work on term 1, and then I'll work on term 2. So with term 1, I'm going to use the distributive property. Negative 3 times x gives me negative 3x. Then I'm going to take negative 3, and I'm going to multiply it by the plus 3y to give me negative 9y. Now I'm ready to work on this second term. However, I do want you to note when I say negative 3 times a 3y, it gives me a negative 9y, and I wrote it with this negative sign and a 9y. So it is actually the same thing as saying adding a negative 9y or subtracting the 9y. Saying it in either one of those ways is correct. So now I'm going to look at this second term and move on. And I'm going to say this is a positive 2 times 2x gives me a positive 4x. The positive 2 times a y gives me a positive 2y. And we can combine like terms. So the y's are like terms, and then the x's are like terms. And I can combine them by the commutative property of addition. I can switch their arrangement and say negative 3x plus 4x. And what I'm saying is I'm commuting these two, and I'm putting the negative 9y plus 2y. Do I have to show this step? No, I don't. But I want you to show that from getting here to here, we really do have a property that we use to get here, to combine the like terms. So negative 3x plus 4y gives me a positive 1x, which we write just as x. We generally don't write the 1 in front of the variable. Negative 9y plus 2y gives me negative 7y. And there is my simplified answer to my initial equation up above. So now we're going to look at a little more complicated problem that have two different statements, one with parentheses, one in brackets. So we have to work in the innermost statement, the 3a plus the 6b. But we can't combine that. So we are now going to have to distribute the negative 2a into this parentheses. But everything else will stay the same. So I'll have the 5, the 3a, but now I'm going to distribute the negative 2a inside the parenthesis. So I'm going to say negative 2a times 3a. And when looking at this, I can put the numbers together. So negative 2 times a 3 gives me a minus 6. And when we have two a's being multiplied together, remember how we rewrote that as a squared. A squared just means a times a. If I had a cubed, that's a times a times a. I could rewrite a cubed this way, or if I have three a's being multiplied together, I could write it as a cubed. So if I say negative 2a times this 3a, I would get a minus 6a squared. Negative 2 times this positive 6b, well, negative 2 times a positive 6 gives me a negative 2, because a negative times a positive gives me a negative. And an a times a b would give me an ab. So negative 2a times 6b would give me negative 12ab. And then we would just add this 6a squared. Now I have some things to clean up inside the parentheses. I see that I have a negative 6a squared and a positive 6a squared. Those two are identical except for the sign in front of them. That makes them additive inverses. So that would be, when I sum those two numbers up, I would get a 0. So now I have 5 times 3a minus 12ab plus a 0, which I could just take off. I wouldn't have to put that step in, truly. So I really would have went from this step down to this one. And now I distribute my 5 inside the parenthesis. 5 times 3a is 15a. 5 times negative 12ab, well, 5 times a negative 12, a negative times a positive is a negative. And 5 times 12 is 60, and there's the ab. So 5 times negative 12ab is negative 60ab. And that would be my answer, my simplified answer to this problem. I hope this first part of working with algebraic expressions and equations has been helpful. Thanks for watching.